I'm glad to be here. This talk is hot off the presses. AI agents as your organization's personal security newsroom. Just a quick overview of what this talk is going to cover. We're going to start with some introductions. We'll go into a background about a bunch of different concepts in the AI agent space and a problem statement. We'll talk some more about core concepts related to agentic AI. We'll talk about building through the actual solution that I came up with for this, what the results of that were, which were interesting, and what some future opportunities are for research in this space or for building solutions within this space. All right. So first up, who am I? As Amy mentioned, my name is Brett Andrews. I am the tech lead for incidents, intelligence, and investigation within Anthropic's security team. What that means is we're the team that is responsible for a lot of different aspects of security operations within Anthropic. That means if there's a technical investigation that needs to happen, my team is the one that works on it. We also develop tooling to support those investigations. That might be forensic analysis of particular artifacts. That might be tooling to assist in the acquisition of specific artifacts to assist in that investigation. We'll develop analysis and reporting on the results of those investigations, and then we'll also run incidents. So if there is any sort of cybersecurity incident, we're the ones who are on call, who get paged, and are the incident commanders for that incident, running it basically from start to finish. So from the identification of an incident all the way through to eradication and remediation of the incident. And then we also have an intelligence function, which is our threat intelligence for the cybersecurity side of the house. That is effectively our bilateral relationships with other companies, whether that's in the commercial space or otherwise, and then also our any other partners that we're talking about for threat intelligence, whether that's a information sharing group like FS-ISAC or something like that people here might be familiar with, or other threat intelligence sharing groups. I've been doing this for about 15 years. I have experience in a variety of types and flavors of companies. I've worked at a small threat intelligence startup. I've worked at AWS for a period of time, helping them with various security problems, and so I've seen sort of the entire side. And I also worked in consulting for a minute, which gave me exposure to a lot of different sizes of and types of enterprises, including things as small as individual restaurant franchises, working credit card fraud cases, all the way up to Fortune 500 companies that were being targeted by advanced persistent threats from nation-state actors. So a lot of different experience with different types of threat actors operating in different types of environments. I've worked on, as it says in the bottom there, I've also worked across red team, blue team, purple team, operations, all the different colors of teams that you can have in cybersecurity. So a quick background here. Is anyone here not familiar with Anthropic and sort of what we do as a company? A couple people. Cool. Just to make sure, for completion, Anthropic is a safety-focused AI research lab. Our founders started it in the United States as a public benefit corporation. What that means is that while most companies have a legal obligation to their shareholders to profit, to, maximizing their bottom line, Anthropic has the opportunity to say, if we are going to release a model and it may be immensely profitable for us, but we believe that releasing that model would not be in the best interest of either the AI communities, the AI safety community, or the world at large, we can make the determination for ourselves of we're not going to release that model, even though it might be the financially disadvantageous thing to do. So that public benefit corporation status allows us to do that in a responsible way. In sort of pursuing that, we've also developed this thing called the responsible scaling policy. If you're familiar with that, or if you're not familiar with that, the responsible scaling policy is effectively our guiding document on how we make those decisions of where we are with model safety. So it basically says that for certain skills or certain capabilities within a model, we're going to keep very close track of that, and we're going to understand what kinds of safeguards and safety is in place. And if those two things are out of balance, that's a point at which we would reevaluate whether we're going to release a model. And as we mentioned at the bottom, we talk about models, we talk about AI. What form does this take for Anthropic? That is a LLM chatbot called Claude. If you go to claude.ai, you can start talking to Claude right now. Please don't, because I'm talking. But you can do it after the talk. So Claude is our LLM chatbot, but we also expose an API, so you can interact with the LLM programmatically and use it in more advanced formats, such as agents, which is one form that one architecture that we're going to talk about today. So the subject of this presentation is largely going to be threat intelligence. So what is threat intelligence? Threat intelligence at its root is a method of optimizing our information environment, right? And it helps us optimize our organization's defenses. So if you think about it, as a building or a castle is your environment, there may be a fog of war around that building, right? There's a lot of stuff that we can't see. We don't know where attackers are going to come from. We don't know what capabilities those attackers are going to have or what they're going to bring to bear against our organization. Threat intelligence is the process of trying to shine a light into that fog and highlight, okay, an actor is over there and that they might be coming at us from this part of the organization. And so, as a result, we can reorient our defenses in a more optimal or efficient way using that additional information. Cybersecurity is a fundamentally information asymmetric game. And so anything that we can do to level that asymmetry between the attacker and the defender, that's the place where cyber threat intelligence can come in and help with that. So one of the big problems in threat intelligence is that the cybersecurity market in particular is opaque. It's very hard if you are a customer of threat intelligence to evaluate how good is the intelligence that you're getting, right? Unfortunately, in government settings, the intelligence cycle is sort of the governing document. And it's a cycle that really tightly binds the intelligence customer to the intelligence collector and producer. And unfortunately, and the market for cyber threat intelligence unfortunately breaks that bond pretty conclusively because there is a market drive to push for being able to sell a single type or piece of intelligence to multiple customers. And that drives you to sort of a one-size-fits-all style of threat intelligence vending on the vendor side. This is not a really great fit for how intelligence is supposed to work. It leads to things like threat intelligence feeds being sold by companies, this is not a talk, very clearly, this is not a talk calling out any particular threat intelligence vendor. This is simply addressing problems that are endemic to the threat intelligence industry. I don't want anyone to feel, if you're in the threat intelligence industry out there, please don't feel attacked. This is a problem that we all have. And both the consumer and the vendor side of this are trying to work together to solve it. But unfortunately, this is an issue, that drives us to have these threat feeds where it's sort of, maybe it's by a vertical for an industry, right? Like there's an energy threat feed, or there's a particular technology stack's threat feed. And unfortunately, those are not super useful to you as a defender because they may not really be tailor-made to your environment. And there may be a lot of noise in there that you have to sort out or things like that. The other big issue that we've seen in the cyber threat intelligence industry, I don't know if anyone is familiar with sort of the marketing things that happen with a lot of threat intelligence reports, or sort of the action figure kind of things that people put out for the different threat actors. They all have different names. The naming convention of threat, don't get me started on that. If you want to talk to me after the talk about the various naming conventions of threat actors within the threat intelligence industry, I will go on a rant, and we don't have time for that. But yeah, it leads to a lot of the conclusion of all of this is that it leads to a lot of misaligned incentives between the customers and the vendors of threat intelligence. Specifically, and lastly, on the customer side, we as Anthropic have personally encountered this on a lot of different occasions. One of the things that we've talked to a lot of different threat intelligence vendors about, and again, we're not shaming anybody here, we've talked to a lot of different people. this is a common problem across vendors. We'll go to them and we'll basically say something along the lines of, what we're interested in is who's most likely to be targeting us, and, or even just like a very small number, like we're, a frontier AI lab, who's targeting that specific niche, not, tech companies, right? But a more granular niche of AI labs, right? There's not very many of them, but who's targeting us or that small group of people who look like us? And also, like, what methods are they most likely to use, or are they currently being observed using in the wild to attack us? Because that's the information that we need to tailor our defenses to the likely attacks and use our limited defensive resources most effectively. The other issue that is more generic and less less Anthropic centric is the regional focus of threat intelligence. It's a largely Western centric industry. It's largely US based and Western Europe based. And part of the reasoning behind that, at least in my experience, and this is sort of a little bit less official views of my employer, but this is something that I have seen working in the threat intelligence industry and having colleagues in the threat intelligence industry, is that there is kind of a pipeline of former intelligence analysts coming out of government and then moving into private threat intelligence. And that is a pretty unique pipeline to Western companies and Western intelligence agencies. And so what that leads to is threat intelligence being somewhat over-indexed on US-based companies, US industries, threat actors that are targeting US entities. And it leaves, regions like APAC or other places somewhat underserved from a threat intelligence perspective. So, what can we do? We have all this problem, and how do we take control of our own destiny and maybe solve this ourselves? So one thing we can do is we can use the tools that we have at hand. At Anthropic, we're big fans of build if we can, and rather than buy. And as an AI lab, one of the resources that we have in abundance is a LLM named Claude that we can use for a lot of different things. I saw a blog post by a fellow named Brendan Dixon, who used to be at Microsoft. He's one of the founders of Passive Total. If you're familiar with Passive Total or for historical DNS lookups, it's a pretty critical part of the threat intelligence industry. But inspired by that, I thought that there would be a way to use our LLMs to basically develop a tailored threat intelligence digest that could solve this gap of how do we get uniquely bespoke tailored intelligence that is related to our organization and that is meaningful and or actionable by us, right? So that leads us into what is agentic AI? So for this part of the presentation, I actually, I said, okay, so what is an AI agent? Why don't we ask an AI agent? So I asked Claude, and Claude responded that, agents are autonomous software that perceives, decides, and acts to achieve goals. So it's going to have a perception. It's going to take in some sort of information, whether that's text, data, the state of the environment. It's going to reason about that data that it's taken in, and then it will leverage that data and make some sort of execution plan and then execute upon it. It may also have some degree of memory to persist either inputs or other relevant status updates across its various agentic states. Another part of agents that is really interesting is that agents can be recursive. So what we can end up with is a really interesting scenario where we have Claudes effectively calling other Claudes as functions. And you can see here from the little diagram, right, you have a little Claude with a megaphone, and that Claude is directing other Claudes to do various tasks for it. So rather than me telling Claude, do this, and then opening up another tab in my terminal or my browser or what have you, and saying, okay, now this Claude do this, and then letting it run, and having to manually orchestrate that myself, I can tell a single Claude, you have access to Claude, and you can basically build tasks on a list and farm those out to other LLM agents and delegate them down, and then let me know when all of that is done, right? So I don't now have to be micromanaging each of those sub-agents myself, which can be a lot of mental load depending on the scale that you're working at. Furthermore, what you can do is you can specialize each of these subagents, right? You can give them different prompts or different system prompts even so that they can handle different tasks in different ways. So you don't have to just have one generic Claude calling another generic vanilla Claude. You can have a Claude that is an orchestrator calling an architect Claude that designs something, and then that Claude hands it off to a Claude that is more specialized around coding, that hands it off to a Claude that is a security reviewer, right, that looks through the code for bugs. And then you have another code that actually is more infrastructure focused, and that one is focused on actually deploying the code out into your environment because it has access to your environment. What this can do is allows you to have a few different positive effects. One of them is you can do this in parallel, right? So that orchestrator agent can call multiple chains of this at the same time and keep track of them. And then also, it can help you with context window size constraints, which is something, if you've played with LLMs at all, you may have run into, if you fill up the context window, Claude kind of may just forget that they know you, right? You may run out of space and you have to start a new chat, and you either have to do something called compaction, where you can basically store that context window in a smaller form and shove it into a new context window, or you just have to write something out to disk and then have the new agent read that in when you're done. But if you have multiple agents, their tasks are smaller. The likelihood of filling up that individual context window is lower. Cool. Right. So our agentic project is going to be very similar. And it's going to probably look like, all Claudes, right? We're going to have an analyst Claude that is going to look at threat intelligence and probably maybe even gather some of it itself, right? We're going to have a developer Claude. We're going to have something that's going to build stuff for us, right? We're going to have an investigator Claude. We're going to have something that might actually look into various pieces of intelligence, maybe try to correlate them together, or things like that. And then we're going to have a supervisor Claude to make sure that everybody's doing what they're supposed to be doing, right? And if we're getting unusual results from one of the sub-agents, maybe that indicates that that agent needs to be slightly tweaked in terms of its prompt, or that there's something else going on that maybe it does need to raise an alert to a human for some degree of attention. And then we have an extra Claude because you never know when you might need one more. They're handy to keep around. So how did I start this project? So I actually started this project by giving Claude the abstract of the talk. So if you go into the out-of-the-box program and you look at the abstract for this project started with me feeding that abstract into Claude along with the design document template that we have at Anthropic for new systems, right? Our design document template is, if you've worked in an engineering company of any kind, it's a pretty traditional design document template where it says like, hey, this is sort of the overall shape of the system. This is the scale. This is the inputs, the outputs. There's some security considerations. Here's some alternatives that are considered. And so I gave that template and the abstract to Claude and told Claude basically, let's go. Let's see what you can come up with from a design document perspective. The first round, of this, Claude developed a project that would be completed by the end of Q1 2026 and would require 6 engineers over the course of 3 months at a cost of approximately $450,000, along with an initial infrastructure setup of around $20,000. So I had to dial Claude back a little bit. I had to explain maybe that's not quite the budget that we're looking for an individual conference talk, Claude. I don't think the return on investment there is probably what we're looking for. So what I basically reprompted Claude and I said, so one thing that Claude needs to understand is it's just you and me working on this project. There is not 6 engineers. There is not $20,000 worth of infrastructure that's going to suddenly appear. It's just you and me. So what can we do? This led to an overcorrection in the other direction, unsurprisingly, where Claude basically stripped out everything interesting about the system and said, well, we could write a bunch of Python scripts and run them together. And I said, well, okay, that's probably a little too constrained for what we're looking for and not super interesting either. So why don't we try something more, in the middle? And the third round, the iteration of our design document, process was actually pretty good. Claude was able to basically take the idea that, okay, we can use a bunch of Claudes where we might be using, engineers in some cases, and And basically, with that resource availability and one person, me, we were able to kind of mock out, okay, this is what the system is going to look like. Yeah, I don't know if can you see this? Yeah. Okay, cool. And so the cool thing about this also is that once we had that design document, we could save that as a markdown, item and pop it into a directory and fire up Claude Code. Has anyone here used Claude Code or played around with, agentic coding like Copilot or something like that? Cool. So Claude Code is a command line tool where you can run it in a directory and you're interacting with the LLM, but it now has access to any files or folders, and also it can run tools like any bash commands in that particular folder. So by dropping the design document as a markdown file into that directory and then telling Claude, hey, let's get started building what's in this design document, Claude came up with this to-do list and then basically started assigning agents to that task, to each of these tasks. So it was, saying, hey, let's build an MCP base class. Let's do this. Let's do that. Let's do that. And it has this nice little formatted to-do list. One of the things that you'll see there is the first task is to develop an MCP base class. What is MCP? Is anyone here familiar with the MCP Model Context Protocol? Couple hands. Okay, cool. So Model Context Protocol is an open protocol developed and shared by Anthropic that lets AI assistants connect to basically any data source or tool through standardized interfaces. It has a bunch of different features, but basically it's a way for us to standardize how LLMs interact with different tools that are available to them. One of the benefits of this is it's open source, so you can go to, I think it's modelcontextprotocol.org or .io, I forget. But you can basically go there, and it's an open extensible protocol, so you can build your own MCP servers. This is all it's a pretty straightforward protocol for that. And there's also a bunch of libraries out there at this point, for a variety of languages that will, allow you to kind of have primitives to be able to build these without having to sort of build it from first principles or scratch. As I mentioned, it's standardized, so you can basically have the LLM is able to interact with these tools in a much more consistent, semi-deterministic way, to the degree that LLMs are deterministic. And then it's extensible, right? Like, because you can build your own. So using MCP, our first step, our being me and Claude, the dynamic duo, was to build a single MCP server for a threat intelligence input. So if you looked at that to-do list, Claude basically said, all right, well, there's a bunch of free kind of threat intelligence type feeds out there. I will pick one and I will build an MCP server around that, and that'll be sort of where we start. And so they picked the US government's NIST, has a national vulnerability database. And so basically it selected that and it said, all right, I'm going to basically build a wrapper around that so that Claude, any Claude, can interact with that NVD, and you can ask it questions, you can query it, but all in natural language, right? As opposed to having to interact with it through an API or anything. Its initial implementation of this, not so great. Claude built a fake MCP server that didn't actually speak MCP and didn't actually talk to the NVD. So it was just sort of mocking things up. It was like, well, if I did this, this is what it would look like, and this is what some of the data probably would look like. So you had to kind of prompt Claude to actually do the work instead of just pretending that it did the work. But some prompting got it to build an actual functioning MCP server. And then to make this extensible, basically Claude took that functioning MCP server, extracted out the specific bits from the NVD, and created that as sort of a Python base class, right? So now we have two kind of foundational components to our system. We have a foundational MCP base class, and we have a working MCP server. And so the next slide, and I pray this works, but there is a video. Oh my God, does it work? Do I have to press it over here? Survey says. Hooray! Okay. So what you'll see here is this is a terminal. I'm going to run Claude MCP list, which is basically listing the MCP servers that Claude has access to. You'll see two here. That's fine. The NVD threat intelligence one at the top is the one that we care about. And then I'm going to run Claude code. And you'll see there's a prompt here. I'm going to say manage MCP servers. You'll see there's an NVD threat intelligence server that's connected. Claude knows about this. It can read it. It's talking to the MCP protocol. You'll see this is the server. And then what it has is these are the different tools that are exposed by that MCP server. So you can actually go through and say, okay, these are the different methods that Claude has created on that MCP server. And then if you go back out, in a moment, what you'll see is because we've registered this MCP server with Claude Code, now in the prompt window, in natural language, I can just say, hey, Claude, what are the 5 latest vulnerabilities from the NVD source? I can't type very quickly. I can talk faster than I can type, apparently. Some typos there. Coming out of this looking real good. And what it'll say is now it does a tool call and it says, okay, I'm going to get the latest vulnerabilities from this MCP server that I know about. It'll ask you for confirmation. And then it'll come back with a JSON object of what those things are. And Claude can then parse that and give out, hey, here are the latest 5 vulnerabilities from the NVD server. So that's pretty cool. Another cool thing that we can do here, is one of the ways that we can leverage this, is, we can now have a registry of these MCP servers that is, basically, a state within our system that says, okay, I understand that these MCP servers are available to me for different intelligence sources. And we can add dynamically to that, right? So now Claude knows what is MCP, how to build an MCP server. It knows that there are threat intelligence sources out there on the internet and how to access them. And it can basically build a compilation of all of those together in a standardized way. So now we have these multiple Intel products in the registry, but it's just raw data, right? So how do we actually leverage that against a tech stack? Well, I am not actually going to show you running against the actual Anthropic tech stack because trade secrets. But what we can do is we can have Claude, oh wait, hang on. I gotta come back over here. What we can do is we can have Claude build mock tech stacks for us. Because if there's one thing generative AI is good at, it is generating things. So one of the things that I asked Claude to do was in a separate window, I said, okay, we need some tech stacks to test this against, right? So I basically told Claude, give me 3 tech stacks that would be common for a small or medium-sized business, right? You could have an e-commerce platform, you could have, a SaaS platform, and maybe one other. And basically give these kind of generic names so that way, if a future Claude is looking at this, it doesn't see like, oh, the Kubernetes environment is the name of the folder or something like that. So it gave me these 3 little random names, and then these are the tech stacks within each of those random names environments, right? And so this gives us 3 different environments that we can start to test against, where we can expose our system to different flavors of technologies and see if it's able to appropriately sift out or filter that some intelligence sources might be more valuable to this tech stack versus that tech stack. An interesting thing also about this that is kind of an aside is one thing that you can do with Claude Code and with agents with coding agents in general is, if you're not familiar with the idea of Git work trees, they can be really helpful for rapidly iterating and assigning a model to basically go do a different branch in the same folder that you're working on, and just have it kind of go off, work on that, push a change, and then see what comes back. And so that's a way that you can basically simultaneously work on 2 different branches in the same folder at the same time without having to run into, oh, well, I'm kind of colliding changes, or the commits are running into each other. Cool. So what ended up happening was Claude then generated basically a tech stack scanner set of code, and we were able to run that against the tech stacks, and this is the output of that. So you can see basically it scans the repository. It says, I detected different technologies, and it says, okay, for this is the tech stack, the raw technologies that are in there. So you can see Spring Boot, PostgreSQL, Elasticsearch, Maven, it says, okay, for those tech stacks, these are typically the critical assets, or maybe it's actually looking at the code and it's saying like, okay, there are critical assets that are stored in these particular places, like it sees reference to a table named customer data or something like that, and it's able to understand that's probably a pretty critical piece of information. It knows, authentication tokens would also be valuable. And then it says, okay, here's the threat actors that would be aligned against that. We'll go into this later, but its understanding of threat actors is not terribly evolved right now. But then it saves the configuration. So it's basically doing this with a single LLM tool call that basically says, evaluate the following folder for what its tech stack is and return, a JSON object that has these kinds of information in it. So this is sort of the what's the right word? This is sort of our foundation for how we're filtering the intelligence into, okay, what's relevant to our environment in particular. So we have a lot of different core components now. How do we tie them together? And the thing that's tying them together, of course, is the orchestration loop, right? This is sort of the agentic core of the system. Unfortunately, I don't know hopefully that's readable. What you can see here, though, assuming that you can read this red on black text, which I should have probably made a different color. What you can see here, though, is this is within the core loop of the system is a different prompt for Claude that has dynamic inputs to it, right? And so what that is you can see at the top, I'll just read this a little bit just to kind of help out for people who are having trouble reading it, but it says you are a threat intelligence analyst because you should always start your prompts with some sort of character declaration for your LLM. It'll really help them out. And then I ask it, identify security items for relevance to our environment. And then the environment configuration is the tech stack that our tech stack analyzer output. The critical assets are the critical assets that our tech stack analyzer output. The threat actors of interest, similarly. The severity threshold is configurable. And then the intelligence items are what we have from our raw intelligence MCP servers. And then for each item, it's basically saying, okay, here's the criteria of, is something relevant to our environment? And then once it has all that, it can tweak it and give it back to you. So what does this actually look like? Is sort of like this. So this is sort of an overview of what the system actually ends up looking like from a kind of block diagram perspective. You have the MCP base class in the top left up there. You can see it has the MVD feed. It mentions a Reddit feed, but we didn't use one of those. It's in there for another reason. It mentions the GitHub feed and generated servers. Those are all going into the MCP registry, which we talked about, right? Which is that stateful, I understand what data sources, what intelligence sources I have access to. And then that is used by the agent orchestrator to effectively gather intelligence and analyze it using the LLM. The tech stack analyzer in green at the bottom is pointed at whatever your environment is. And that will basically tell you, okay, cool, great. This is the stuff that is relevant to me. And it feeds back into the agent who then uses the adaptive orchestrator to perform additional filtering, surface gaps, and potentially generate new sources. Now, you may notice that the right-hand side of this is stuff that we haven't really talked as explicitly about yet. And that's because we're going to. So one thing that this system can do that's pretty neat is it can look at the registry of MCP servers that have sort of the totality of intelligence information that system has access to right now. And it can look at the tech stack and say, okay, these are the relevant technologies. And it can hold the two up against each other and say, well, is there a technology in here that we don't have threat intelligence about? And if so, it can also use the internet to go out and say, well, is there possibly a source that would be valuable for us to actually add via an MCP server into the totality of our intelligence collection? And that would basically, then it will generate on the fly, it'll code that MCP server, add it to the registry, and now we have an additional source of threat intelligence based on our tech stack specifically. And so this is an output from running that, where basically you can see it said, okay, cool, great. I looked at this environment. I found, Django. I found Spring. And I identified the need for a new data source. And I added Maven Central Security Advisories and Kubernetes CVE feed for comprehensive container and build infrastructure coverage. And so it actually did two sources as one MCP server, which that's just a prompting thing. You can fix that in the prompt and say only make one thing for each server. But in this case, it just combined the two into one and made another MCP server. So now within all of our sources of intelligence data, we have a new source that is tailored specifically to the environment that was analyzed. And then, it says, what you can see in the bottom there on the final summary is original MCP servers, which is the ones that were running already when the system started, was 3, and generated MCP servers is also 3. So in the course of analyzing the tech stack, Claude found 3 different opportunities to get new sources of intelligence and added them to the registry, which is pretty cool. One thing that is also worth noting here is that you can also have additional loops inside the generation of these new MCP servers. So one thing that I was running into when I was building this initially was it would generate an MCP server, and I don't know, if you've ever zero-shotted LLM code, it works like 85, 90% of the time, but usually there's some subtle error that you have to kind of like tweak or whatever. But I can add an agentic loop that just says, if it doesn't run the first time, here's a few common things that are probably the problem, and you should just debug it maybe 3 to 5 times and see if you can fix it yourself. And if you time out 5 times, raise your hand and say, I need an adult or something like that, and you can come call for help. But if you can fix it yourself, that's great, because that's less interaction that I, the human, have to do with the system. And so this thing actually, I think in this instance, when I went and looked at the logs, it actually did identify an error in this generated MCP server. And so there's a retries equals 1 where it actually went in and said, I think that's not it. Yeah, here it is. Yeah, so this is actually the code for the retries. For the self-healing, where it says, okay, here's a new prompt while you're building it that says, the generated MCP server code failed. Here's the error. Here's, this is however many attempts that we have. So there's a variable for however many attempts. And it says, this is attempt blank of 3. Please fix the code so it works correctly. And then it basically has some reiterations of how the code is supposed to work, what the data structures are that it's supposed to be dealing with, so that if it generated something and it just didn't have the fields right or something like that, it's an easy fix. And then it also says return cannot fix if for some reason you can't figure out what to do. So, this is all great, right? But has anyone heard of the lethal trifecta? No. Okay, cool. The lethal trifecta is something that is a relatively new concept within LLMs. I think it was coined in like June or something. But it's basically the idea that there are 3 things that can cause you security problems with LLMs. Basically, if you have sensitive data, if you have access to the internet, and you have untrusted user input, all being handled by the same LLM. And unfortunately, if you kind of do some math in your head as I'm saying those, you'll realize that this system has all 3 of those potentially. And so one of the things that we have, at least, is untrusted data, right? We have data coming in from raw intelligence sources into this system and being used, as I showed you, in prompts, right? That is, I don't know if anyone saw the talk at the end of the day yesterday on offensive uses of agentic code and against LLMs, but that is a really juicy opportunity for attackers to do nasty things such as prompt injection to your system. As it mentions at the bottom, we're taking in a lot of random text and we're parsing it in LLMs. And now the good news here on the mitigation side is this system is largely read-only right now, right? We're not actually we don't have access to the infrastructure. We're not actually pushing code into things other than building these MCP servers, which are just further reading devices. So there's not really an opportunity to do as much. You could prompt inject and make a malicious MCP server, which would be bad, because that is code that is running somewhere in our environment. But At least in my case, I'm running this in a sandbox, and you're not going to really be able to get much out of it. And we also don't have, a lot of tool calls that have actual code or anything like that. How would we mitigate this? One of the things that we could do, we could run this through some sort of other, filtering function before we, pass the raw intelligence into the prompts, right? So one of the things we could do is for instance, we could strip non-Unicode characters that if we know we're only expecting normal text, right? Unicode characters being used in sort of the ASCII smuggling attack from yesterday, and also just are commonly used in various forms of prompt injection. Also, if we expand this, right, like we might have more risks if we made this into something where maybe it does have access to the rest of our security ecosystem, for instance, like if it's pushing things into our SIM, you could see prompt injection that either deprioritizes alerts or has other nasty effects on the overall security system. And so that might be bad. One thing that we could do at that point is we could basically run classifiers over either the tool calls or the input of the system itself to see if there's anything that flags as malicious injection. So once we've talked about that, let's talk about the output. So what does this actually give us right now? Currently, all it does is it will send you a nice little markdown report. Because as the title of this talk is, this is a security newsroom, all they do is they give you a journal or a magazine or a newsletter, right? That's all they're doing right now. And so currently, yes, it's just a markdown report. And you can see a screenshot of kind of what it looks like down there. It says like, hey, here's the key metrics. Here's our top threats, right? This could easily be expanded, right? This was partly a factor of just time and resources on my part that it's not. But you could make this into something where it gives you daily updates in Slack or Teams or whatever, your messaging platform is at your company. You could also, if you wanted for your executives, you could do something exciting. You could make this into a podcast that your executives can listen to. Executives, as far as I understand, love podcasts. I don't know why. But you could use text to speech and basically have it give a little podcast, that says like, hey, these are the threats that are relevant to your organization. You could also make it so that it tailors the report to different departments, right? So maybe you have a tech stack where, you have certain programming languages that are in use, certain libraries, and you have an application security department that really cares about supply chain security and, safe programming and things like that. You could tailor a threat intelligence report to them that focuses more on application security issues. And then if you had, the Kubernetes stuff from earlier, you could take that and funnel it into a separate report for your infrastructure or your networking team, right? So that could be another way that you could use this tool. So we're talking about potential expansions. So what other things could we do with this? This is the system as it currently stands with, basically a week of work on my part. And Claude obviously spending significantly more of a week, but what is time to an LLM? So what now? We can look into the future and we can see what other cool things might we be able to use this for. One of the most obvious things, to me anyway, was Claude picked a bunch of things that are pretty structured text, pretty standard database, standard feed type databases for its intelligence sources. So it was basically picking vulnerability databases, things like that. It would be great if we could expand this out into, less structured text. Could we get, more detailed articulation of threat actor profiles? I don't know. I mentioned earlier, we were going to come back to it, when Claude sort of said, oh, well, your threat actors are APT nation states, ransomware, and other stuff. That's not super useful from a threat actor perspective. So we could definitely serve to get more granular in that form. And also currently it just says APT threat actors, like as if they're all the same, which is definitely not the case. You could also take incorporation of less overt sources, where LLM interpretation could provide a differentiator, right? So you could look at, things like, blog posts about like a proof of concept that someone has for something, and maybe it hasn't been assigned a vulnerability yet, but it's showing that I found this issue with this particular thing. And then it could classify that into your threat intelligence system and alert you about that. What else could you do? You could take multi-modal sources, right? All of this right now is just text. So one thing that we could expand this to would be I mentioned podcasts earlier in terms of generating them. We could also take them in and turn them back into text because it's all just data. And so we could take podcasts via automated transcription, turn them into text, and try to pull either interesting vulnerabilities or indicators of compromise out of that we're then putting into our threat intelligence platform. We could also take video, recorded contalks like this one. It's a meta joke. And YouTube videos or something like that. We could auto transcribe them. We could also take OCR of individual slides and use that to turn it into text and then feed that into the platform as well. One thing that I thought was a really fun idea, threat intelligence can sometimes involve scraping or monitoring of hacking group platforms. So you could talk about, IRC, Discord, Telegram. You could expand this LLM capability into automated development of sub-agents that are infiltrating those environments and bringing you back raw threat intelligence from those environments. Telegram bots are super easy to write. Also, I legally have to say here, check with your legal team before you do this. You might make them very upset if you do this the wrong way. So this is not me saying just go forth and do this. And especially if you do this with Claude, please be gentle. It's a very innocent creature. But yeah, you could basically do this and have an entire agent-based network of different personas that align to different hacking teams that show up in different forums or different Telegram chats or Discord servers or things like that. Another thing that you could do is, so we've expanded we've standardized our inputs. We've got this raw field of intelligence that we're building MCP servers around to make it all easily understandable and compilable by Claude. But what about the output? The output right now is just a report. But that requires some sort of human intervention to be actionable, right? Our MCP server is currently kind of one way going inbound. What if we started building MCP servers that worked the other way, going outbound from our system into the rest of our security ecosystem or environment, right? What might that look like? That might look like incorporation with a vulnerability management product. It might look like, in integration with a SOAR platform. If we see that there are vulnerabilities in a public-facing thing, we could potentially either isolate that automatically or declare an incident and pull in humans to start responding to that. I'll actually tip here. We in terms of using Claude in sort of an incident response or investigative type way, if you look up on YouTube, a colleague of mine at Anthropic, Jackie Bowe, has given a talk at B-Side San Francisco about how Anthropic is using Claude in that context specifically. So if you're interested in either sort of incident response or investigations within an environment and using Claude for that, I strongly recommend that you check out her talk. Another thing that you could also use here, I don't know how many people, if any, were at DEF CON or saw some talks that came out of DEF CON, which was also this month. One of the things that was there was DARPA, which is the United States government's Advanced Research Projects Agency, was sponsoring a AI competition where it was basically looking for, can AIs find and patch vulnerabilities within systems very quickly? And so you could imagine having a threat intelligence platform interfacing with a vulnerability patching platform could be very useful, right? Because now you can see, okay, this actor is using this particular vulnerability. We know this actor is likely to be targeting us, and we have access to an MCP server that says, is this vulnerability present in our environment? And if so, go patch it. Without having to involve a lot of change management and a lot of different teams across the company. All right. That's the presentation. I was told to prepare an FAQ in case there weren't questions. Amy, how do you want to do this? I have questions that I can ask myself if no one wants to ask me questions.
Let's see. Show of hands. Anybody who has any questions for Brett?
Cool. All right. We're going for it. Will this be released? No. That's an easy one. This is a pretty rudimentary tool. It's me and Claude going over it in about a week. It's not really designed for production consumption, but it's designed as a proof of concept of what you can do very rapidly using the LLM tool. As you saw, this was a lot of stuff in a pretty short amount of time. Some of it's unpolished, but that's, the nature of the beast. And as it mentions here, it's not hard if you were looking at this presentation to go into Claude Code and basically rebuild this thing or something like it yourself. So you could basically use that as the starting point of your own production version of this service if you wanted to. Cool. And still no questions? I got more that I'll ask myself. All right. What alternative solutions or methods were considered? In our case, the chief alternative considered was do nothing. Largely because we are a very small security team. Threat intelligence is probably out of the three portfolios that I mentioned in my team, incidents, intelligence, and investigations. Intelligence is, even though it's listed second for, I guess, alphabetical reasons, it's not our primary focus or even our secondary focus. It's probably the bottom of our priority list after incidents and investigations. That is what we are doing on a daily basis and day in, day out. And so this is not something that we had at the top of our list. And if we didn't come up with a good solution to sort of the problem that I was discussing at the beginning of the talk regarding, the vendor mismatch with the threat intelligence industry, we would probably just have not bought threat intelligence products and we wouldn't have built anything. And it would have just sort of been like, all right, well, we have less information. That's a bummer. Yeah, cool. How does the system handle non-English sources? Not bad is the answer. It's basically dependent on Claude's overall linguistic ability. If you're interested in this from sort of non-English language sources, you can go, there's a link in the presentation, which you obviously can click on because you have it. But yeah, there is an official docs page for language support, within Claude. And it will give you, I think it's MMLU is the benchmark that we use for, what our linguistic capability is against, a range of different, global languages. And most of them are pretty good. Obviously, it's going to scale pretty linearly with how much of that language is available on the internet. So the less that language is online or available in some sort of text format, the less that we're going to have skill with it as the LLM. Cool. All right.
Any questions from the floor? No? Yeah. One second.
Do you have any publication about this topic?
This is the publication.
Okay.
Anyone else?
Can you share a little bit more on how you use Claude and topic, like for the software development lifecycle or any security operation?
Yeah, so the talk that I mentioned from my colleague is probably a really good place to start on that, in terms of what we're talking about publicly. Obviously, there's going to be some stuff that we're using it internally for that we're not going to talk about publicly. I will say, it is definitely something that I use on a daily basis and that my colleagues use on a daily basis. We try very hard to integrate it into most of our workflows, not only from a dog fooding perspective and kind of understanding what our customers are going through, but also we're a small team and we need all the help we can get. And if we can throw a bunch of clods at the problem, that's really going to take some stuff off our plate.
Thank you.
Hello, thanks for your talk, the first one. And what do you think about the new kind of attacks that are arising with MCP servers? Because you can, an attacker can inject code on the repositories, persistence.
Yeah, so I kind of glossed over this. The joke here is the S in MCP stands for security. It was not designed with security in mind, is my understanding. And so there is kind of a big warning on use of MCP right now that it's not a robust protocol that has a security layer over it. I know there are a couple of both open and closed source projects that are working to incorporate security into it, whether that's signing MCP servers or adding other sorts of basically authentication or reliability methods to MCP. But right now it is definitely, it's more of a, it's a tool that I would be careful about using in production and very aware of what the limitations are on the security side if you were going to throw this into a production environment. That's a good point.
Thank you.
I would like to ask the question about the OT security. So does Claude implement anything that is specifically for the OT one?
OT, by OT, do you mean operational technology like ICS SCADA?
Yep. That.
Yeah. I mean, that to the degree that intelligence is available about that on the internet, Claude could incorporate that into the platform that we're describing. We can talk more offline about it if you like, but in my experience, there's not as much of a difference, especially on the threat intelligence side, there's not as much of a differentiator there, between OT and IT, cybersecurity. Obviously, once you get into the infrastructure and the environments, there's going to be significant differences in how you can operate, but at the intelligence layer, it's basically it's a different technology stack. So you would be analyzing the technology stack, and it would filter the raw intelligence differently than it would for an IT environment, would sort of be the answer.
Okay, thank you. So yeah, I do have another question regarding the MCP server. So if I want to build on my own, and do you think what is the most thing that I should concern to safeguard the MCP server?
So the question is sort of best practices in security for MCP servers. Is that sort of a question? I don't have a good answer for you on that right now. I could probably point you to some resources either from myself or some colleagues later, but I would have to get back to you on that.
Thank you.
Thank you. We have time for 2 last questions. No? Okay. Well, Brett's slides and presentation materials, along with all our other speakers, will be made available online and fairly shortly. If not today, then over the next few days. So, and he will be around as well during the rest of this event, as well as lunchtime if you have any other questions. Thank you very much, Brett. Really appreciate it. That was a fantastic talk.
Big thanks to Amy and Dylan for organizing all of this, and the Out of the Box crew. Y'all have been great, and thank you so much.